Hello everyone, my name is Hao Lu and I'm a master student in the Department of Plant Science at University of Manitoba. Today I'm going to talk about investigating quantitative trait loci, also known as QTL, for lodging resistant in brassica nipis using the 60K aluminum aphelium array. First up, I would like to start with a little bit introduction about brassica nipis. Brassica nipis generally refers to canola. It is the alloploid species that forms an interspecific cross between Brassica ripa AA and Brassica oleracea cc, and it accounts for 14% of oilseed production globally. Canola can be used for many purposes. For example, canola oil can be used as cooking oil, but it also can be used as ingredient in cosmetic products and lubricant in machinery. Canola meal can be used as protein isolate for human consumption as well as for animal fats. One of the major problems with canola production is lodging. Lodging is referred to a permanent displacement of the plant from its vertical growth habit, and lodging causes a reduction of grain quality, grain yield, and make it difficult for mechanical harvesting. There are many factors that controlling lodging, such as biotic factor, abiotic factor, and genetic factor. Lodging can also be improved by the use of plant regulator to shorten the plant height and effectively control lodging. The use of dwarfing genes has also been introduced to brassica nipis to shorten the plant height and improving lodging. However, the negative impact of using these dwarfing genes is the delaying flowering time in brassica nipis. Despite all the effort to controlling lodging is still remain a concern for canola production, and the demand for this crop is expected to increase in the next few decades. As you can see from the graph on your right hand side, showing the use of agricultural land in Canada for canola production between 1986 to 2021. This graph shows a significant increase in land use with an estimated of 6 million acre land use in 1986 to up to 22 million acre land use in 2021. So the overall objective is to identify QTL associated with lodging resistance in brassica nipis and molecular marker closely linked to lodging resistance. There are three main objectives I would be focusing on in my research project, which including objective number one is to phenotyping two brassica nipis double haploid population for lodging resistance and determine whether genotype differences in each population have a significant effect on lodging resistance. The objective number two is to genotype these populations using the 60K alumina aphelium SNP array and determine suitable marker for genetic mapping. The objective number three is to identify QTL associated with lodging resistance in these DH population using QTL analysis. For an interest of time, I will only show the experimental design for objective number one. As you can see from the diagram over here, double haploid lodging 1 was produced by crossing between a female with a lodging score of 5 and a male with a lodging score of 1 to producing F1 individual. Double haploid technology was applied to producing DH population, and 198 DH line was used for phenotyping. Similarly, double haploid lodging 2 was a product between a cross of a female with a lodging score of 5 with a male with a lodging score of 2, and 184 DH lines were used for phenotyping. These DH populations will grow on the field using a randomized complete block design in 3 replications per locations, and each row is 3 meters in length, and each row to row is 35 centimeters apart, and it's carried out in multiple locations over the 2-year span. Lodging resistance is visually assessed. A lodging score between 1 to 5 is given to each row depending on how well it stands from the ground. For instance, the lodging score of 1 is given to rows that standing straight at approximate 90-degree angle from the ground. Number 2 lodging score is given to either all plants from that row are leaning slightly or a few plants is down. A lodging score of 3 is given to row that either all plants are leaning more than 45-degree angle from the ground or 20 to 50% are down. Lodging score of 5 is given two rows that either all plants are leaning less than 45-degree angle from the ground or 50 to 80% of the plants are down. And the lodging score of 5 is given two rows that all or most plants completely lie flat on the ground. For statistical tests, ANOVA test using linear mixed model was applied for individual site year analysis as well as combined site years analysis. In the individual site year analysis, genotype was used as a fixed effect, while random effect is for block. In the combined site year analysis, genotype was also used as a fixed effect, but in the random effect site year, and genotype by site year was used as a random effect. And from what we know that a shorter plani tend to be more lodging resistant. A phenotypic correlation between lodging score and height was also conducted. A table for single site year analysis for CBLD1, also known as lodging population number 1, showing a significant genotype and block effect for all three locations. A mean lodging score for 2020 CM is 2.15. For 2021 CM a 2.96 and 2021 PT a 2.84. Similar result was obtained for ANOVA table for single site year analysis for CBA02. There was significant genotype effect across all three locations. A block effect was only significant in 2021 CM and 2021 PT. However, for 2020 CM, the block is not significant. Mean lodging score for 2020 CM is 1.69, 2021 CM is 2.65, and 2021 PT is 2.21. When it comes to per ANOVA, where all the locations were combined for analysis, CBLD1 show a significant genotype and site year effects, while genotype by site year show no significant effect. Similarly, for CBLD2, genotype and site year will show up as a significant effect. Genotype by site year show as no significant effect. For CBLD1 correlation analysis, the graph shows a negative correlation with the R value of 0.5 between plant height and lodging score. Similar result was obtained from a correlation analysis of CBLD2 with a negative correlation between plant height and lodging score with the R value of 0.52. In conclusion, for the objective number 1, there is a significant genotype effect in single and pool ANOVA in both study populations, which confirming that there is a genetic factor that is attributing to lodging score variation in the two populations. The negative correlation with the R value of approximately 0.5 between plant type and lodging score. This result is unexpected because we were expecting that shorter plant height is more resistant to lodging. For the next step, I would be focusing on genotyping the two populations using Brassica 60K alumina phenol array, and the result is pending for analysis. And after that, QTL analysis will be used to determine QTL associated with lodging resistance. And the significance of this project is that once QTL and marker that are closely linked to QTL are identified, they could be used as a marker assist selection for lodging resistance in Brassica napus L, which in turn allowing plant breeders to accelerate the selection process for lodging resistance. And with that, I would like to thank my supervisor, Dr. Robert Duncan, field technicians Judith, Rob, and Mike for their tremendous help during seeding to harvesting of my crops, and Agriculture Agri-Food Canada from Saskatoon for helping me with genotyping, and my committee members, Dr. Kurt McCartney and Dr. Jason Morrison. And thank you for everyone for listening.